In this lesson, we'll take a look at exponential functions and how to solve exponential equations. An exponential function can be written in one of two ways. The first way an exponential function can be written, f of x is equal to a raised to the power of x. Notice that in this particular function, a has to be a constant number between 0 and 1. The variable x is actually in the exponent. In this particular instance, if the base a is between 0 and 1, the function appears as so, and it's decreasing and continuous on the entire domain from negative infinity to infinity. This is a one-to-one function. The x-axis acts as the horizontal asymptote, and the graph passes through these points. -1, comma, a raised to the negative first power, and remember a would be the base of your exponential function. It passes through the point 0, comma 1, and it also passes through the point 1, comma a. The second way in which an exponential function can be written, the base a is greater than 1. So the function f of x is equal to a raised to the power of x. The base a must be greater than 1. This particular function takes this shape, and it's increasing and continuous over the entire domain. This is also a one-to-one function. The x-axis serves as a horizontal asymptote, and the graph passes through these points. -1, comma a to the negative first power, 0, comma 1, and 1, comma a. Let's take a look at some additional properties of exponents. For any real number a is greater than 0, where a is not equal to 0, the following statements are true. A raised to the power x is a unique real number for each real number x. The second additional property, and this is the property that we'll use in order to solve type 1 exponential functions, a raised to the power of b equals to a raised to the power of c. If that's the case, if you have the same base, you can set your exponents equal. B equal to c. Addition property C says m is less than n if and only if a raised to the power of m is less than a raised to the power of n, provided that a is greater than 1. M is less than n if and only if a raised to the power of m is greater than a raised to the power of n, provided that a is between 0 and 1. So in this example, we're asked to solve 81 raised to the power of x equal to 3. My intent here is to rewrite both 81 and 3 as having the same base. We can rewrite 81 as 3 to the 4th power, and we'll raise that to the power of x, and 3 has an understood power of 1, so I'll just attach an understood 1 power. From the rules for exponents, when we raise a power to a power, we multiply, so I can multiply 4 times x, so that's 3 raised to the 4x power is equal to 3 raised to the 1st power. I'll now use the drop the base. Since my bases are the same, I can drop my base and set my exponents equal. And now I can solve for x. So I'll divide both sides by 4, and x is equal to 1/4. Let's take a look at another example. Here we're asked to solve 5 raised to the x minus 5 power is equal to 625. So here we'll solve this equation for x. Again, I'll try to make my bases exactly the same. I can rewrite 625 as 5 to the 4th power. So I'll keep my left hand side as it stands, 5 raised to the x minus 4. I'll rewrite 625 as 5 to the 4th power. I'll now drop my base and set that's x. Let's take a look at another example. Here we're asked to solve 5 raised to the x minus 5 power is equal to 625. So here I will make both of my bases base 5 because we can write 625 as 5 to the 4th power. So I simply bring my left hand side down, 5 raised to the x minus 5. I'll rewrite 625 as 5 to the 4th power. I'll now drop my bases and set my exponents equal. X minus 5 is equal to 4. I'll now add 5 to both sides. And I have x equal to 9. Thanks for watching.